Hello, everybody. Welcome back to this month's Footsteps to Mars Hangout. This is our first Thursday. We've switched days from Fridays to Thursdays now, and so welcome. I hope we were able to get a lot of you able to make the switch over to our new day. As usual, we're doing it's the first Thursday of every month, so this must mean we're talking about Mars, and we've got experts from from Lockheed Martin and Boeing, but the private sector, working on getting us to Mars, and we're going to talk to them about what they're doing and some of the plans that they've laid out in getting us going to Mars. But before I do, I want to say a couple of things about these Hangouts. We are doing these every week now. We're going from doing the first Friday and the third Friday. Now we're going to the first every Thursday at this time. So look for us on DeepAstronomy for a variety of topics, and we will keep you informed through our social media channels at DeepAstronomy what we're doing and when. So I just wanted to let you know that as well. And these Hangouts are also endorsed by the American Astronomical Society and the American Astronautical Society. And what that means is that we try to highlight the science, or they help us highlight the science and technologies behind a variety of human spaceflight efforts, Mars, of course, being the topic of today, but we also talk about the future of space and what are the members of these organizations doing to get us both astronomy and space flight. So I want to give a shout out to both AASs for helping support us in this or endorsing these efforts and helping make their members available to us. So, and I'm going to introduce our guests, I promise, but I want to also let you know how you can interact with us. The best way to do that is with Twitter. The Footsteps to Mars Hangout or hashtag is right there. That is the best way. I've got it sitting up on my other screen here where I'm looking at the Footsteps to Mars on my tweet deck, and already I'm seeing people tweet at us. I see Andrew Planet. He could make it. I'm glad you could, Andrew. Welcome back. Also, Patrick Freeman, and he's tweeting at us. I see you guys. Please ask, as our Hangout progresses, if you'd like to ask questions of our guests, please do it that way, and I'll be sure to read it out to them. Okay, and joining me let me start with my co-host, Dr. Harley Thronson is here joining me. He helps us set these up. He's an astronomer at NASA's Goddard Space Flight Center. Hi, Harley. Welcome back.
Yeah, I'm glad I made it to Thursday as well.
Yeah, yes, it was a bit of a challenge getting all of our minds around this new time and day, but I promise it's better for all of us, and hopefully it's better for you. Let us know on Twitter if this date and time is a problem for you, and we can, I don't know what we can do about it, but at least we'll know. At least you'll be able to see the
We'll say sympathetic words.
Yeah, we'll say you're right, because we really are probably going to stick with Thursdays at 3 o'clock. And Alberto Conti, who normally joins us, isn't here this week. He is traveling. He made some kind of thread about joining us en route to another place, but I'm not sure if he's going to do that. Right, Harley?
Let's hope not. Let's not encourage him.
Yeah, let's not encourage him.
Yeah, he's called us in from his automobile, driving, I think, through Mountain View.
That was just a little bit scary. Okay, so all right, well, let's get to the topic of today's Hangout. We are going to be talking about the pathway to Mars, a new pathway to Mars, where there have been over the past couple of decades, there have been some really impressive advances in thinking by the private sector on how we should get to Mars, what technologies are going to be necessary to get us there, what sort of operations are we going to need to set up, and in particular about habitats, bases, and things like that. What are we going to need in long-duration spaceflight? And so we've got members of the private sector here, experts who are working on this, and joining me is the right before I introduce my guest, let me just also mention that that while both AAS organizations do endorse the Hangouts themselves, they do not endorse the content of the Hangout. The things that we say are the views, the expressed views of the people who are attending the Hangouts, and not necessarily reflective of the views of the two AASs. So I wanted to make that clear before we go. How did I do, Harley? Is that good?
That sounds good to me.
Okay, good. All right, so now here we go. Joining me from Lockheed Martin is I have Tim Cichan. He has the greatest job title in the world. He is a space exploration architect for Lockheed Martin. Hi, Tim, and welcome.
Welcome. Thank you.
Also joining me right next to him is Steve Jolly, also from Lockheed Martin. He is the chief engineer for civil space. Hi, Steve.
Hi, how are you doing, Tony?
I'm doing well. Thanks for joining us. And from Boeing, we have Darby Cooper. He is the launch vehicle architect for the Boeing company. How you doing? How you doing, Darby?
I'm well, Tony. Good afternoon.
Good. Okay. Well, let's get started, and I want to start with we'll start with Tim and Steve real quick. Give us some background on what Lockheed is doing. What are some of the big efforts that they've got going for getting us to Mars?
Maybe I'll start, and then Tim, you can pick up. So, Tony, about 8 months ago, we got together and said we really ought to be looking at how to put together a plan to get to Mars in a sooner time frame than what's been talked about in the general public. We felt like maybe something in the 2030s and 2040s was just too far out for anybody to grasp. So we started from the premise of let's take with what the taxpayers have already created in the number of elements that we might need to go to Mars, and that was the SLS, the heavy lift vehicle that Darby will talk about, and then the Orion multi-purpose crew vehicle, which Tim and others have worked on a lot here. And starting from those two elements, what could we do to pull off something sooner? But rather than just having an open-ended idea of what to do, we said, let's go wrap it around science. And so we got together with our scientists and scientists outside to say, let's come up with a mission set that actually will move the needle in the science realm. Now, we did take cues, and I want to make sure that this is clear. We took cues from other studies that have been out there. People have studied all the different ways to get to Mars, what to do there. And one of the more recent ones was the JPL, we call it the minimalist study, but it was Scott Hubbard, Hoppy Price, and the scientists and engineers from JPL and Stanford got together and said, hey, you could go there and do an orbital mission first and then go down later. So that's something we picked up on. And so Tim and other architects here conjured up a way of starting from those two elements and using basically high TRL and TRL that can be made high technology readiness level, for those who don't know that acronym. What if we could do something as early as 2028, which is the architecture that we've now proposed. Now, before we enter all the discussions of it, I want to say that it's Lockheed Martin cannot go to Mars with our own architecture. Boeing can't go to Mars with their own architecture. This is about having a national and international conversation about what the next program of record should be. So, although we have synthesized and are proposing an architecture, we really want it to be a discussion that's out there for everybody. So,
okay, all right, Tim, do you want to add anything to that?
No, I think the key things are that we wanted to have a vision out there from our perspective that was pushing to 2028 based on Orion and based upon the activities that need to happen in the cislunar proving ground through the 2020s.
All right, why don't you tell us what cislunar is, since you used the word?
Sure. Cislunar in general just refers to, within the gravitational space of the moon. So in orbit around the moon, and not necessarily, low orbit, but it goes up to the high orbits, like we're talking about for the asteroid redirect mission.
Okay. And Darby Cooper from Boeing, let me get you. Give us a little background on what you're working on there with Boeing in terms of getting us to Mars.
Well, I have sort of two roles. I have what I call my day job, and of course that is really focused on the production and build of the Space Launch System. So we're in production for the first set of flight hardware, and for the EM1 mission, now about 2 years from that flight, and then of course we're actually already starting on the EM2 mission, which will be the first one where we take crew back into the lunar environment, as Tim mentioned, in the cislunar proving ground. My other part of my job is probably relevant for today's discussion is I'm the launch vehicle architect. So I make sure that all of our SLS elements and our plans for changes to SLS are consistent with the different exploration frameworks that are being developed and sending us on that path to Mars.
Okay, I'm going to get to the SLS, the Space Launch System, here in just a minute. I want to show a couple of a really cool diagram that you sent me also. But before I do that, I want to ask both groups here, what is driving you guys? I mean, Lockheed Martin guys, you guys are working on this. I mean, I know that NASA has contractors. I know that they, people get contracts to build things. But it sounds to me like when I heard Steve talking there that you guys were doing this as kind of interior driven, right? I mean, there's no what drives you guys in doing this research and this technology development. And I'll start with you guys at Lockheed, maybe Tim and Steve.
Yeah.
Do you understand my question? What I'm asking?
I think so. And just to be transparent, Tony, I mean, our colleagues at NASA and at Boeing and Rocketdyne and all the others, we all have been talking about Mars for a very long period of time, since Viking, really, right? And then the Space Exploration Initiative in the early 90s, many of us worked on that in various forums. And so I think Mars is one of those destinations that reaches deep into the emotions of people. So there's this human element of wanting to go there, and obviously, with all the talk about colonizing Mars and many people going there, that it reaches across society, it reaches across party lines. But I think we're a scientific organization, and we're driven by science discovery, along with our partners that we put together deep space exploration missions with. And so we're kind of a little bit nerdy in the sense that we would like to go and see our own feet there, but we would really like to move the needle in the science realm. Where did we come from? What happened to Mars? It appears to have undergone some climate change, if anybody's looked at pictures. and there's the search for life and origins and understanding the solar system. So it all sounds maybe a little bit crazy, but we are the type of people that are motivated by those things.
Great.
And
go ahead, Tim.
Yeah, we've always had, a small advanced programs group work in these advanced architectures so that we understand where we're headed, what are the good uses for Orion, and what are the next things that are coming. And from the Red Rocks and Stepping Stone missions and even further back, we've always got that technology focus on. We need to understand where our customer and partner NASA is going and how we can help them do that. And the best way to do that is to go out and to design these Mars architectures and evolve them and change them and learn from that process.
Okay, and Darby, I think this question might be a little bit easier for you to answer, since some of it is, but you've got the SLS is a very defined project that is being developed, and so what I want to do is I want to put up this graphic here, this one of the Space Launch System, and let me click over to my icon there. There we go. And this is what you guys are working on. This is what's going to get us off of Earth, right, and up into space. Why don't you tell us a little bit about this?
Correct. I mean, and that was the whole genesis of the Space Launch System when it was formulated in both the NASA concepts and then in the rest of the agency and the funding that has come with it, was to create a vehicle that would allow us to leave the Earth's gravity well and explore beyond low Earth orbit. And so from the get-go, SLS was designed to do that. And so the graphic that you're showing shows, I'll say, the 4 main configurations that are contemplated for the vehicle. The left-hand side of that is the SLS Block 1 configuration. That's probably the one that folks have seen the most of. It will fly first. It uses the 5-segment solid rocket boosters that are heritage back to the Space Shuttle program with all of the lessons that were learned along the way in Constellation. It utilizes a modified Delta IV upper stage as a way to control and manage costs for that early configuration flight. And then, of course, you'll see the Orion multi-purpose crew vehicle as its principal payload. We are quickly evolving, and we've been able to do that through a lot of our affordability initiatives to the Block 1B configuration. That replaces that Delta IV-derived upper stage with an exploration upper stage, and that enables a great deal of mission capture. So Tim mentioned all of the Proving Grounds missions in the cislunar space. Certainly all of those can be done with that Block 1B configuration. and we believe that one will fly as early as EM2, so the second SLS flight will most likely be in that configuration. Shown on the right-hand side are then also the cargo configurations. And so for the first one, the Block 1B cargo, you'd have to develop the large diameter payload fairing. Obviously, that's a fairly straightforward engineering problem. And then as the needs and the missions evolve, Steve mentioned how the studies have evolved in terms of how you get to Mars and what the technology is needed. It is contemplated that the SLS might need to have a little bit more performance, and so we'll achieve that either with upgrades to the Block 1B configuration, or if necessary, we'll have a larger step, if you will, into that Block 2 configuration shown over there on the right-hand side.
Okay. And so and they're all using, it looks like, the same engines, correct? RS-25 engines at the bottom.
They're right. The core stage always uses RS-25 engines. Of course, they will go through their own evolution, if you will, as we deplete the engines that are left from the space shuttle program, and then move into the new build engines. The Block 1 and Block 1B all use the same 5-segment booster. There may need to be some changes to the booster if we need the Block 2 performance. And part of the studies that are ongoing right now is really trying to determine how much performance we need. Those studies are starting to, I'll say, coalesce around given mass numbers and performance numbers. And so we may be able to do even the Mars missions with the Block 1B configuration.
Okay, I'm trying to see the difference between Block 1B and Block 1, and I guess I see that there's this adapter, and then it looks like you've got an interstage with an upper.
Correct. The big difference is the upper stage. So in the Block 1 configuration, the upper stage is a small diameter stage that is essentially the same diameter as Orion. Whereas you'll notice in the Block 1B configuration, that larger diameter goes up the stack, if you will, much further. And so that is the large exploration upper stage, which uses the full diameter of the Space Launch System. Okay.
Well, it looks like, let's see here. Let me go find my Hangout so I can stop sharing my screen. There we go. So this is one of the plans in the works to get us up off of the planet Earth. And of course, as Darby mentioned, there's a couple of configurations that are going to fly first that contain the Orion module. Steve and Tim, can you guys talk a little bit about that? And do you want me to put something up to talk about it, like maybe one of these images?
Yeah, I think if you want to talk about the near-term missions, I don't think you provided it. Yeah, so Tim maybe could describe EM1 and EM2.
Sure. Yeah. So the EM1 mission for Orion, first flight SLS, second flight of Orion after the EFT1 test flight, unmanned test flight to the moon. It will go into the distant retrograde orbit, which is a high orbit around the moon, and it's about a 25 to 26 day mission, and then we'll come back and re-enter at Earth, testing out all the systems of SLS and Orion, taking lots of data and getting ready for the next flight, EM2, which will be the first crewed mission of Orion and SLS. And we're working on what that mission will be, but many of the concepts have us, and the current baseline have us going into orbit around the moon. So the first time for people to leave low Earth orbit since 1972. So EM2 is a great mission. And then moving past that, NASA is working on plans for a cislunar habitat. So as we talk about EM3, 4, 5, we are demonstrating living and working in deep space with the initial habitats and under the NASA's Next Step program. Both Lockheed and Boeing and I think and a number of other companies are working on that. And so those are the early missions there to put a habitat in orbit around the moon.
Is this graphic that I have up the one you're referring to? This?
Yes, that's the Boeing version. That's a great graphic of their concept for the Next Step habitat. Okay.
And what do you? And let me see. There's another one here. Let me. I'm sorry. Now I've got all my things. Should I put up the Oh, I hear it is. This timeline graphic would be a good one for what you guys are doing.
Right.
This one, right?
Yep. So in our Mars Base Camp concept, which is looking further out than the near-term missions, now we're talking about a crewed orbital mission to Mars. So not landing on Mars. We think that the necessary and prudent step is to go into orbit around Mars first. And you see in the upper right that Mars Base Camp vehicle that pushes off to Mars. But as you look at the timeline, what we need to do before we're ready to go to Mars is a series of increasingly more difficult missions, building up prototypes of the Mars Base Camp vehicle, testing them out, going on longer and longer excursions in orbit around the Moon. And then as we get towards closer to the 2028 date, then we're also starting to pre-deploy elements of the Mars Base Camp architecture as well as robotic scientific spacecraft. So starting in the 2024 to 2026 timeframe. So everything's in place when we set off for Mars on 2028.
So these, let me get it up here. So this one, no, that's not it. So this graphic here, the one with the timeline, we've got you in the next couple of years doing the Orion vehicle certification to the Moon and going in orbit, like you said, and then this EM2, the start of the outpost assembly, which you're sort of projecting to be around 2021. And then a couple of years later, this doing some cislunar science with different assets right here, right?
Right.
And then,
Yep.
and then you're saying that the next stage is the one that says Mars 2026 and this what you're calling EM6 and 7. These are robotic, or no? Just the Mars 2026 one is.
Yeah, the Mars 2026 is an example graphic of a pre-deployed robotics to Mars.
Okay.
Yeah, and I think to make sense of those later missions, we almost have to explain the chronology of how the base camp gets in place.
Okay.
But what Tim and the other architects have done is they started from the vision of what the mission would look like in 2028 at Mars, and then they reverse engineered back all the way to EM1 even on the kind of things that would be necessary to demonstrate. And that's one of the advantages of having a vision or an architecture that you can aim at, because then it brings into relevance all of the missions that lead up to it. And so that's what he's got there. And the reason that there's a Mars mission in 2026 that he showed there is because of the use of solar electric propulsion and needing to pre-deploy elements of the base.
That's right. We've talked about that in previous Hangouts. So that's a big technology that's going to be pretty important in getting us where we're going. Okay, well let me so Darby, let me ask you about some of the things you guys are doing while we're in the cislunar area. I just had that one up. Let me get it up again. So maybe you could talk a little bit about it as well. This is, I believe it's this one. Am I right? Is this the one? Yeah. These are the habitats that you guys are working on, right? For getting us.
That's correct. Let me emphasize first a little bit to follow up to what Tim and Steve were saying. It's very important that we do this in a logical sequence, using the lunar environment to prove out and test the technologies. Just to put it in context, of course, I think many people who are listening today are familiar with the recently completed year in space. And so that was a single crew that spent 340 days in space aboard the International Space Station. We're contemplating Mars missions that will be at least double that or towards 3 times that duration.
That's a good point.
The whole point of these exploration habitats, the next step concepts that industry is working on, is to develop the systems that are needed to go stepwise and take that mission duration. The Apollo missions spent about 30 days in lunar orbit combined. And if you heard Tim talking, we're going to start to increase that by 50% and double that very quickly in the SLS Orion cadence in the early 20s. But obviously to go from spending 20 or 30 days in the lunar environment to spending nearly 1,000 days transiting from the Earth-Moon system to Mars and then back again needs a very well thought out and a stepwise approach. So yes, the graphic that you're showing is that is our Boeing internal concept. Just like Lockheed, we have our advanced group that does our internal thinking. Very similar in the overall purpose of the vehicle, slightly different solutions. You know, you give two engineers the same problem, you'll always have nuances to that solution. But we also have the solar electric propulsion system, which could fly as early as EM2 or EM3, and then a sequence of pressurized modules that provide the necessary systems to sustain the crew. You'll see that Orion, obviously we'll use Orion as our deep space crew vehicle. And in our plan, we would also build this up in the early sequence of the SLS launches. So from EM2 through the EM4-5 time frame, you would use the SLS co-manifested payload capability to take these elements to the lunar environment. They can be assembled there, and then you essentially have the in-space assets that are needed to make sure you have the right life support, the right logistics, and the right health considerations for doing those long-duration shakedown cruises. That was on Tim and Steve's graphic about having a long-duration test mission, if you will, in the middle 20s time frame. And then after that, you could be in a position where you are ready to go on that Mars orbital mission that Tim and Steve and the rest of the community have been talking about.
So this graphic is highlighting the stuff you're going to be doing near the moon, and I'm noticing, I don't know if it's coming across because of the compression of the Hangout or not, but the video. But down at the bottom there, you have durations outlined for what these different missions are supposed to do. M2 in
Correct.
2021, for example, is going to be for 14 days. M3 for designed for 30, M4 for 60, M5 for 90. And M6 for 180 days. So these are your attempts at getting longer and longer mission support for different. And you've got these all look different. All of the habitats are actually different looking to me, right? Are they?
Yeah. Each module of this habitat complex has a slightly different function, if you will. And so you'll notice one of them has an airlock that would allow us to, of course, go do EVAs or spacewalks in the lunar environment. You'll notice some of them have more docking ports, less docking ports. And then on the internal outfitting, of course, is where the real difference is in terms of the different systems that are needed, the life support, the water scrubbers, the carbon dioxide management, and so on. And then, of course, for folks who are listening, also all of these graphics are available on the BeyondEarth.com website, and so folks can go study them if they're having trouble seeing them over the Hangout today.
Oh, good. And I'll put that link on the description box after the Hangout is over as well, so you guys can go. So thank you. So the idea then, so make sure I'm understanding this graphic. We start with this mission gives the power bus, just get power out there. So all of these are designed then to be added over time, correct?
Correct. So you'll see that, you're right. There's about 4 elements, if you will, that formulate this in-space habitat. And again, they're all designed to be launched in sequence, if you will, using the SLS co-manifested capability.
Oh, okay, cool. And so these are the and the time frame around here. Again, we're looking at the mid-2020s or so before when these are the early to the mid-2020s to get these things going. How is there any driver for doing these times? Like, let's say, how can I ask this? If you is this timeline? Are you pretty confident that you'll be able to do these things by the mid or the early 2020s?
Certainly, I think so, Tony. Given the funding that the programs have received, right? So you'll notice this. We talk about the 6 easy pieces that you need, right? And so we've talked about how SLS and Orion are 2 of those pieces that are essentially in production now. Orion, I just saw the other day, the heat shield arrived at the Cape for EM1. The pressure shell's been down there for several months. We've are about to complete the first flight hydrogen tank for the SLS core stage. The solid rocket booster segments are being cast out in Utah at our orbital ATK partners. And so given the available funding, the cadence that we've laid out, and the graphic that Tim and Steve showed with that flight cadence through the early 20s to emplace these assets and then prepare for the long duration missions and then on to Mars, I think is very achievable given the current budget, given the status of the programs, and essentially we've I'll say done fairly well to date. And of course, I always have to knock on wood when I say that because it's a challenging development environment.
Great. Okay. Well. Okay. Steve and Tim, we've been talking about getting setting the technological framework or the foundations using cislunar missions to test these habitats, to assemble these habitats, and things like that. You guys have a really, and when we had the timeline graphic up where we were talking about getting to Mars, there's this one really cool one that I want to talk about now that you guys have that you guys are putting together, and this one. This is what you guys are working on, I believe, for getting to Mars, correct? This is going to be a setup that you're going to put in orbit around Mars, right?
That's correct.
Can you tell us a little bit about this?
Sure. So this is the Mars Base Camp vehicle as it looks in Mars orbit. And I'll walk through the different modules, but the first thing that strikes you is it's very symmetric. That's by design. We need to have system redundancy and self-rescue capability because aborting from Mars is not really an option. From the space station, you can be down on the ground if there's some emergency on the space station in about 90 minutes. From the moon, and if there's an emergency and you need to abort to Earth, now we're talking maybe 5-6 days. And for Mars, it's not. You can return early, maybe, depending on the orbital mechanics, and we're talking about months.
Yeah, we've talked about the different Mars orbit configurations and how difficult some of them are to get home from. So yes, it is an issue.
Yep. So as we walk through the vehicle, you see that there are 2 propulsion stages. There are 2 Orion spacecraft, and
one here and one here.
Yep.
This looks like 2 things pushed together right there.
Yep.
Is that what they are? Am I looking at that right?
Yep. And then as you walk in, you've got the propellant tanks there, the orange tanks. Inside those propellant tanks are the main crew quarters, and we do that to surround the crew with as much material as possible for radiation protection. And then you see the
that's cool. That's scary and cool at the same time. Living inside, right, with hydrogen tanks right over your head could be scary, I guess, but it's also comforting to know they're providing protection.
Right. And then coming into the center of the vehicle, you see the convex-shaped habitat and laboratory, giving the crew additional living space on the habitat side, and then on the laboratory side, really a science laboratory in orbit around Mars is the capabilities of that. And then we have a center node which has cupolas for viewing as well as the excursion system. And so the other feature of the vehicle is that the Orion and 1 propulsion stage and that excursion system airlock can separate from this vehicle and do a 2 to 3 week sortie mission to either Phobos or Deimos. And then the plan is to have a crew of 3 of the 6 astronauts do those sortie missions. The other main piece of the operations that we're proposing for Mars orbit is to operate rovers and other robotic assets on the surface of Mars using telepresence. And so as well as being able to get samples on those sortie missions from Phobos and Deimos, and having those robotic assets on Mars launch a Mars sample into an orbit near Phobos for that Phobos sortie to pick up.
So wait a second. This here, where it says Orion, this whole bit here, and there's another one on this side. This would detach and go to the moons of Mars?
Yes.
Wow.
And the concept was that the crew would be split. It's a crew of 6. You'd take 3, and they would go off on their excursion, and the other 3 remain with the mothership. And if anything were to go wrong, we can go get them. So as Tim was trying to emphasize, and Darby brought it up too, it's a long way from home. So Apollo 13-like scenarios are going to happen, and you're going to have to get yourself home and get yourself safe. And so this idea of redundancy and being able to do excursions to the moon for the science reasons, and then be able to rescue yourself as part of this entire architecture, which is why it has that push me, pull you kind of look to it.
Mm.
So how?
I want to say, I think it's one of the cleverest ideas, which has been around for a while, is pre-positioning. You guys want to say a few words about that?
Yeah, sure. And if you note in the upper right-hand side of that graphic is a picture of.
Sorry,
There we go. Is a picture of us pre-positioning using solar electric propulsion spacecraft, that center node, and the Phobos Deimos excursion system. The other piece that is pre-positioned in Mars orbit of this base camp vehicle is the laboratory. But then that allows that transit configuration. It still has the 2 Orions, which are the command and control vehicles. It still has 2 crew quarters, and so it still has a lot of redundancy there for any issues.
And I don't know if Tony and Harley, if everybody understands the profound nature of this ability to pre-place with high ISP systems, as Darby was showing earlier. The one graphic he had up where you pointed out the solar arrays, I mean, we should all step back and say, my gosh, these are new. We've taken ComSat technology, essentially, is what's underway right now, and boosted it from, say, 18 or 20 kilowatts up to 40 or 60 kilowatts or beyond, and we can use ion propulsion systems to haul large masses. That laboratory that is being described by Tim is got maybe 17 metric tons in its total mass of pressurized volume, and we think several metric tons of shirt sleeve science equipment inside. Nice. And we can put that there via the SEP tug, if you will, starting years before the humans show up. And so Tim and his team have decided, let's put everything that's not critical to human survival there ahead of time, and that those elements that are required to get humans there safe and back will be with you the whole time. So in this mission, there's no refueling or transfer of propellant or anything that needs to take place. You have, on your way, you have everything you need to get home and to abort if you have to.
And including, your reentry vehicle.
Right.
So by taking 2 Orions, and we've built the architecture around the capability of Orion. It is the world's first deep space human spacecraft, building on Lockheed Martin's a long heritage of building interplanetary spacecraft, and as well as things like F-35. And so that Orion spacecraft is the command and control, and it is the reentry capability. And we are crafting the return trajectories to enable Orion to be that vehicle.
So when you're talking about pre-positioning, then are you just saying getting the tugs, putting the stuff out there, putting it in Mars orbit, or are you also talking about assembling them before the humans get there? Like these different pieces that are already sent out, will they assemble themselves, or are they going to require people to go out there and do that?
So there's rendezvous and docking when the main interplanetary stack arrives, and so we haven't shown the magic that takes place once you're there, but you will reconfigure with the elements that have been pre-positioned in order to assemble the base camp. But it would be nothing more than standard rendezvous and docking like takes place with Space Station already.
Okay.
I've got a question for you all. Back to the timeline. This is terrific. Doing great things sooner than later is always an intrinsically good idea. What were the particular constraints that set for you all in your scenario set the mission to Mars in the late 2020s? What all went into that timeline, or the far end of the timeline, the late 2020s timeline?
Well, we started with a non-technical target where we told the architects and the engineers we would like to be there sooner, and of course you're on 26-month centers, right, for the best launch opportunities, and 2028 happens to be one of those 26-month centers. There were other rumors that somebody might have picked it because it's the 75th year of the summit of Everest, but I will neither confirm nor deny that.
I was wondering if you were going to bring that up.
But you have to start with a target and then say, what's the art of the possible? So we told Tim and his team, let's start with 2028, tell us what you can do, and then we look to see if it fits into Darby's team's SLS development and the frequency in which they can launch at, the mass that we need to get up to an assembly node, either in low Earth orbit or a high Earth orbit, and then and how it all fits together and whether it holds together. And remarkably, they came back with this 2028 architecture that seems to fit all of those criteria. So it really started from a non-technical perspective, Harley.
Oh, got it. A follow-up question. This I think for our audience, we don't want to get too much inside baseball type questions, but there also is, on top of it, as you said, there's the relative orientation of the Earth and Mars orbit that allows these 26-month windows where they're very advantageous to send missions. There also are 13 or 14, I forget exactly when, year year orientations on top of that, and there is a particularly good one, a particularly good low energy one in the early 2030s, and which is why a number of scenarios are looking at the early 2030s. But you guys decided to go about 5 years earlier.
Well, I mean, part of it is if we're going to be a spacefaring world and you want to go to Mars, we have to be able to overcome the those opportunities that aren't at the lowest energy state.
That's a very good point. Yeah, if you want to be able to be, as you said, a spacefaring nation, you have to be a spacefaring nation.
Right, and I think that the 2033 that you're referring to still is there, and we want the very next mission to go down to the surface, okay, with humans. So
that was going to be one of the next questions. Have you gone? And again, I think loads of people who work in this field recognize there are some real attractive engineering, technical advantages to your early mission, maybe your early missions, to remain in orbit. You can carry out a lot of science, experiment, demonstrate that you can even do it. But of course, eventually humans would like to go to the surface. And then have you guys given thought in your scenario building to what and when a mission that could take humans to the surface would occur?
I'll let Tim start, and then I'll pick up.
Sure. I mean, the short answer is yes. We're thinking about what is that next mission? How does what would we like a landing mission to look like? How do we enable? How do we use Mars Base Camp and this architecture to do that landing mission? But we're still working on that, so we don't have details yet.
But I think we can say that all roads, in my mind, lead to supersonic retropropulsion in order to land large masses. And so for the people who aren't into that term, it's pointing the fire end of the rocket into the wind as you come in, and to land a large mass on the surface. And we are working on concepts. Other people have proposed those too. But the key thing here is that in the Mars Base Camp architecture, we leave a laboratory for the next mission. It's there with significant power. It has like 40 kilowatts of power and significant sample handling capability. We can't ignore the planetary protection side of this, and I know that you all on this Hangout have had discussions about this before probably, but the ability to be able to quarantine and handle samples, to certify landing sites, I use that term loosely, but to make sure that where the humans are going is not a danger to them or anybody that they would return, we think is a key issue that this kind of architecture allows for. And so it is a necessary step, as Tim said, in our mind, in order to actually land on the surface. That's me talking. That's not a company position. But it seems to me that it would be prudent to do this. And we get to do global sampling in this architecture, not just from a few sites, but from many sites. And we're working with the scientists and getting into the scientific community to have these discussions about what the investigations would look like, and so that we can form this architecture around real science principles and not just ideas of how to get people there.
Okay, and while we're on this topic, and I want to get Darby's input on this as well, because you also have a timeline. Let me put this up here, where you've got a pathway to Mars, where you are, where we're talking about getting. We've already discussed the proving ground missions that you guys were working on with the cislunar space and things like that in the 2020s, and then Why don't you talk a little bit more about this particular graphic that you guys are working on over at Boeing?
Yeah, Tony, and I think that's a good compliment to what Steve and Tim were talking about. So if you...
Oh, yep. You may be muted.
Okay, how about now?
Oh, we can't hear you. Okay, I don't think I have you muted. Nope. Oh, he just dropped out. Okay. Well, here we have, so hopefully he can come back and talk about this a bit, but this is some of the stuff that the efforts at Boeing have also mirroring. It looks like to me some of the stuff that we're going on with.
He's back.
Oh, he's back.
Tony, am I back now?
Yep, there you go. We can
All
hear
right,
you now.
sorry for the tech glitch.
No problem. So, yeah, I was just hoping maybe you could talk a little bit about this graphic on the Boeing side.
Yeah, and I think it's a nice compliment to what Tim and Steve were talking about, because we've all been talking about. I'll start on the left-hand side with what we call the 6 easy pieces, right? And so if you start from the top, you need SLS, you need Orion. Obviously, those are now in production. The next two are the Habitat, and then the solar electric high-efficiency propulsion that Steve was talking about. And then now we're starting to talk about those last two pieces that you need to do work on the surface. You need an entry system. We've shown one of the aerodynamic decelerator concepts, essentially a big inflatable heat shield. Certainly that would be complemented by the retro propulsion that Steve mentioned. And then also you'll need the ascent vehicle. Everybody wants to come home. And so that is what would enable the humans' boots on the ground, final leg, if you will, of the Mars exploration.
Okay.
To complement what Steve was saying, and just put that in perspective, you'll see our timeline is a little more focused on the Mars missions, I'll say in the early 2030s, mid-2030s then for the landing mission. If you look at that landing technology, we think that might take a little bit longer to develop. You know, today we're able to land about a metric ton on the surface of Mars, and I think Steve mentioned we're going to eventually need to land things that are 15 or 20 metric tons on the surface in a single chunk. And so that technology will take some time and, of course, some funding to develop. However, the orbital missions, I think everyone agrees, those make a lot of sense. And having that ability to do the telescience where you don't have that 40-minute round-trip delay, I think that would be great. I think it was one of the panels that Harley put together where one of the current scientists for the robotics missions mentioned that their 90-day rover mission could have been done in about 90 minutes if they'd been, you know, a suited person on the crew at that site instead of the time delay, stop and start with the rover. And so I think having these plans, having this stepwise approach, identifying what the needed technologies are and the sequence that they're needed, trying to do things, I'll say, as soon as you can, will really actually let us get there and turn this into a reality.
Okay. We've got a lot of people commenting. I want to get to some of our comments here as well. But before I do, I just want to ask you guys, and this is for both groups here. Is there any sense? And I need to be. So I'm wondering about duplication of efforts. Are you guys working with each other? Are you guys building? Are you not? Are these two parallel efforts between the two companies to get us to Mars, or is there? I know that in one case, you know, Boeing is using the Orion crew capsules and things like, and that technology that's built elsewhere. But do you see much working together here and getting? And is that happening?
It is happening, and I think you sort of see it in both architectures. In that, you know, we're not building the Boeing system, and we're not building the Lockheed Martin system. We're saying here's some ideas for NASA to implement, and not just NASA and the international community. And so, you know, we expect that different companies and organizations will design and build the different modules and pieces of these architectures.
Yeah, I think, Tony, the way, and interesting to see how Darby answers, but I've been trying to draw us to the science that we want to do at Mars, which has everything to do with, it doesn't have anything to do with technology, it has to do with discovery. And I think that both companies are saying, hey, let's get a vision out there. and let's get it to be a program of record so we can all get our fingerprints on it, all help. And then, the companies sometimes are competitors, sometimes are teammates. We'll all go compete in good spirit for the various elements that remain on that. And that's what we're excited about, because then we move everything forward. So it isn't a Lockheed Martin vision. I don't think that Darby would say it's a Boeing vision. We really were trying to get a national and international vision established. To do that, you have to throw things out there. They have to have some coherence, and then we have to sit down and debate them and kind of work through the architecture.
Yeah. Darby, do you want to comment on that?
Yeah, I think Steve said it fairly well. I mean, if you look at the history of aerospace, right, it is a fairly friendly industry, and as he mentioned, there are times when we compete against each other, and there are times when we team together, and we all really are after the same outcome, that outcome of exploration, of being able to leave low Earth orbit and go explore again. Certainly, I like Steve's idea of you have to throw things out there and see what sticks, right? So you'll see that the ideas are sort of coalescing around the concept of doing these lunar missions to test out systems and technologies and to get ourselves used to operating away from the Earth again. The overall concepts of how you get to Mars are starting to be very similar. They all have a habitat. They all have some science. They all have solar electric propulsion with chemical propulsion. You're seeing the best minds of the industry sharing those ideas and refining them, and of course some of that is done in a competitive environment, some of it's done in a cooperative environment. So I think advancing the discussion is the important thing. I think that's why both of the companies represented here today, as well as many others, are putting these ideas out there for the community so that they can be shared, that we can learn and cooperate where necessary, and of course when the competitions happen, we'll go compete. But we've done all of that before, and it's sort of like a good old school rivalry, right? You know your rival really well, and you don't mind playing them. So.
Good. Okay. Well, we're running out of time, and I want to make sure I get to some of the comments here. George Caldwell is asking a good question, and maybe this one is good for you, Tim. I'm not sure, since you are the space exploration architect. But he's asking, what is the biggest challenge in getting to Mars, and what will be the biggest challenge once we're there? So as you're building your architecture, what do you guys see as the biggest challenges? And I'll start with you, Tim, and each of you can comment.
No, I think the biggest challenge is designing an architecture that has all the reliability and robustness that we need in a very challenging environment, both from radiation and the long duration space flight, and returning back from Mars, being able to put together a mission that stays within the budget that NASA has. And so there isn't, or I guess what I'm saying, it's not one challenge. It is putting together that architecture that solves the problem, and fits in the budget to do. And I think that systems engineering problem is really the difficult one, that crosses both technical and political and financial. Steve, did you have?
Well, I would draw I would answer it this way. When we have interplanetary missions, we have fixed launch dates that we have to meet. We have science that we've decided that must be done, and we will not go below it, but we'll de-scope everything in order to hit that launch date. I think that we have to have the same mentality if we want this to happen. We need to pick a date, decide what the minimum is, and then we need to tailor ourselves and control ourselves in order to get there, because there's a lot of things that can happen in 10 or 15 years.
Darby, do you have a comment on that?
Yeah, I guess I would echo some of what Steve and Tim have said. I think keeping stable funding is very important to letting the programs progress and evolve. And then I would also, we mentioned it a little bit earlier, I think the evolution of the mindset. We're used to operating close to home, and where problems are fixed by returning to Earth. And we're going to step out away from home, and we're going to go to places where you're days at first, you'll be days from returning to home, and then eventually you'll be potentially years from returning to home. And so that will take a different mindset in terms of how we address the problems, the types of contingencies we plan for, and the types of resources that we'll want to deploy with the crew to give them the best chance of executing that mission. And of course, we want to get them home safe.
Exactly, and I tell you, every time I do one of these Mars Hangouts, I am constantly impressed by the thinking that's going on and the level of detail and the planning that's going into it. Technically, getting to Mars can be solved. I am totally confident. And Harley, one day I'm gonna ask you to get us some policy people on here to talk about this idea of consistent funding and space policy and to me that's the weakest link. That's my personal opinion. The weakest link in the system.
We got some policy. We got policy people.
Yes, and so because these guys are going to build it, there's no question about it. These guys know what they're doing. They can build us and get us to build the spacecraft and get us to Mars. It's everything else that we just. Oh my goodness. Well, okay. So so that was a good question, George. I appreciate that. Whoa, Vanderheide, you're back. Great to attend a live hangout again. Looking forward to an hour of cutting edge Mars science. Thank you, Wout, and it's good to have you back too. I'm glad this time is working out for you. Patrick Freeman is commenting that Orion mothership looks really cool. What are its dimensions inside and outside? Tim and Steve? I think he's talking about that one.
I don't know that off the top of my head.
No, well, I was looking it up. The pressurized volume inside is on the order of, I want to say, 2/3 of space station. Okay, and so that gives you an idea. And we're at what, 135 metric tons approximately in the Mars configuration. So that gives you a sense. So that's somebody else will have to do the conversion to pounds. But
yeah, did he specifically mention Orion, or was he asking for the whole Mars?
I think it was the Orion. I think it was this, the Orion, with the Mars orbit configuration from. I think it was this one. Let me just put it up here real quick. I think it was this one.
You can pull up that graphic, for a sense of scale. The conic habitat section is about 9 meters long and 7.5 meters wide, and so the whole vehicle is about 60, 70 meters long.
It's on the scale of a space station in terms of its size.
Oh, okay.
Right. It's on the scale of the space station, but it is not quite as big inside as the space station. I think the habitable volume is about 2/3 or so. Yeah.
Oh, okay.
And then mass-wise, it's also a little bit less mass than the space station, but a lot of that mass is propellant. So we're talking about a vehicle here that's not quite as big as the space station.
Yeah, so it's not a space station. Let's make sure it is an interplanetary vehicle.
Right, exactly. Good distinction. Okay, thank you, Patrick. That was a good question. Andrew Planet, we're running out of time here, so I'm going to try and get this one in. Andrew Planet is asking, is it possible, and Steve, this goes to your comment about using rockets to sort of blast into the wind, as I believe the way you put it, to get us to Mars. Is it possible to use aerodynamic balloons to aid landing or elevate spacecraft on Mars despite the low atmospheric pressure? Any chance of using balloons?
Well, we are looking at balloon concepts for atmospheric studies. It is approximately the same pressure as you'd have at 100,000 feet in altitude. So we do fly balloons, that high and way beyond. So it is possible to lift it. Probably nothing like a habitat, but for science instruments and reconnaissance, we are looking at new classes of spacecraft and science craft, we call them, that could be operated from the base camp or from the surface.
Okay, cool. Good question. All right. Well, so we are running out of. We've only got a minute left. Before I leave, I want to thank all of you guys for leaving your questions and comments on Twitter. That was really good. I'm sorry I couldn't get to all of them. We got into the discussion really in depth, and so I wanted to make sure we covered some of these things. If you want to go and get some of these graphics, there are two places you can go. For the Lockheed Martin one, I'll put both of these links, by the way, in the description box below the Hangout once we're done, so you'll be able to just click on them. But Darby, what was the URL that you had told us earlier about downloading?
It's beyondearth.com.
Beyondearth.com, very easy. And the other one, and the one that I'm looking at for Lockheed Martin, has got lockheedmartin.com/US/SSC/Mars-Orion. So that's another one that you can go to see the Lockheed Martin graphics as well. But again, like I said, I'll put the links in the description box so you guys can do it. Okay, Harley, we are done. We got another one. I want to thank all of our guests. I want to thank all of you. I want to thank Tim Cichan and Steve Jolly from Lockheed Martin, as well as Darby Cooper from Boeing, taking time out of their day to tell us what their efforts are, their various companies' efforts are for getting us to Mars. You guys rock. Thank you guys for working on this. This is exciting stuff, and I can't wait to see the 2020s now come along and see some of these things happen. So, and by the way, I think the next SLS launch, Darby, is, if I'm not mistaken, is sometime in 2018. Is that right?
Yep, we're targeting September of 18, so should be quite the show.
I'm going to be down here checking it out, so that'll be a lot of fun to watch the progress of that as well. So I want to thank you guys very much for attending. Will you come back, by the way? This is my standing question. Will you come back when you guys are making more progress and tell us how it's going?
Of course, absolutely.
Awesome, great, thank you.
Be a pleasure.
Okay, on a programming note, we are going to be back next Thursday. We're doing these every week now, where we will be talking about something I'm sure you guys have heard a little bit about. Harley, you want to give them a little preview?
Yep. A week from today, we will be talking about this recently discovered planet, apparently Earth-like, orbiting the nearest star to our own, the Proxima Centauri B planet.
Yep, and we will also have my good friend and colleague Carol Christian. She'll be back joining us as well with this hangout, so you can look for her back there. She also had a little comment. I'm going to read your tweet, Carol. This was back when we first started the hangout. She said, "Yes, we rogue scientists speak our minds, even on hangouts." That was where I had to do that disclaimer. So anyway, thank you guys. That's it for this week. We'll see you guys next week, where we'll be talking about exoplanets and Proxima Centauri. Thank you all for watching. I hope this new time is working for you. And as always, keep looking up.